Hi everyone. In this video, let's understand the network design criteria for Amazon EKS cluster. In the previous video, a day in the life of Amazon EKS cluster, we saw that there is a preparation stage, and during the preparation stage, network design is very important. So let's understand what are the various criteria and requirements we need to keep in mind before creating a cluster. Let's get started. Say we are deploying the EKS cluster in the cloud, and there are three availability zones. This is a very good practice for high availability and resiliency. The first decision we have to make is the EKS deployment model. In this section, we are only talking about deploying the EKS cluster in the cloud. But there are other deployment models where we can deploy EKS cluster on-prem using the EKS distro or EKS anywhere or EKS and outpost. But for this discussion, let us assume that it is deployed in the AWS region. And we created an EKS cluster which creates control plane in AWS managed VPC and in AWS managed account. Now the data plane is created in the customer VPC, the customer managed account. Both the data plane and the control plane are connected via cross account ENIs, elastic network interfaces. Very important decision we have to make is with respect to the VPC CIDR size. What should be the CIDR size so that we will not have any issues in future when we scale the applications with respect to the IPs. Many customers complain that there is an IP exhaustion issue if they are using EKS VPC CNI, but it's not really true. This happens due to misconfiguration. Let us understand how to solve this. Let us say we created a VPC in the customer account with a size of /16, which brings 65,536 IPs. These IPs can be used for both pods and the nodes in the cluster. These IPs are sufficient for pretty large clusters. In case if additional IPs are required, you can always add additional CIDR blocks to the VPC. So by default, VPC CNI allocates IPs from the VPC to the pods and the nodes. Let's look at another use case where we have some applications running in the corporate data center and we need to connect these applications to the applications running on the EKS cluster. Let's assume that the customer VPC in the cloud is connected to the corporate data center via transit gateway. Now, in this case, what should be the VPC CIDR size? Now, one more thing we need to keep in mind is the RFC 1918 CIDR limits. Many organizations will use these RFC 1918 series for many applications. These applications will be running across the clouds in the data center. So, for example, let us allocate a saddle size of /20 from RFC 1918 series. This brings 4096 IPs. And how do we avoid IP exhaustion issues? Because 4096 IPs may not be enough for a large cluster. In that case, let us attach one more CIDR block to the VPC, and this CIDR comes from 100.64 series, which is non-RFC 1918 series. This CIDR block brings 65,536 IPs. So we can use these IPs for the pods and the IPs from 10. Series can be used for the nodes. So this is one way we can avoid IP exhaustion issues in EKS cluster. So what next? Once we decided the CIDR size, then we need to decide a number of subnets in the VPC. Should we require a public subnet and do we require a private subnet? We need to decide. If you have any applications running in the cluster which needs to be exposed to the clients outside via internet, you can deploy these applications in the private subnet and expose them via load balancers which are running in the public subnets. So this is one common use case. If you are running a private cluster, which means there is no connectivity to the internet, then you can remove public subnets. You can only have private subnets. It's always a good practice to run all the workloads in the private subnet. Another important decision criteria we have to think of is creating a separate private subnets for connecting the control plane and the data plane. When you create an EKS clusters, we need to provide the subnets in which the EKS service will provide cross account ENIs. It's better to have a dedicated subnets for connecting control plane data plane. And for running the workloads, you can have huge shader blocks for the private subnets. Only the nodes and the pods can run there. Whereas the subnets used for creating the cluster can be used only for connecting control plane and the data plane. There are some recent announcements where you can modify the initial subnets that you provided when you create the cluster. Though this change is available, it is recommended that you create a dedicated subnets just for connecting the controller data plane. This is important because tomorrow when you upgrade the cluster from version 1 to version 2, we require some extra IPs. These IPs will be coming from the dedicated subnet. Apart from this, do you require a database subnets? In most of the cases, if you have some specific security constraints where you do not want to expose the databases to outside, then you can create database subnets and create the routing table accordingly. If there is no separate security constraints configuration for database subnets and the private subnets, it's better you can have one single private subnets where the databases and the pods and the nodes can run. Now, let us take a summary of how the network design criteria should be taken care of. First, choose the right EKS deployment model, be it on-prem or in the cloud. Once you decide on the deployment model, I would recommend you do a load test for your peak traffic to estimate how many pods and the nodes are required at scale. This will give us a good number of IPs that are required so that we can configure the shader block sizes. Then we need to decide the size for the shader block for the VPC. And if required, EK supports adding additional shader blocks to the VPC as well. Now we need to create the required number of subnets, public, private, databases, and separate private subnets for connecting the control plane and the data plane, and with the right sizes to avoid IP exhaustion issues. And last, we can configure the VPC CNI networking plugin to leverage the IPs properly for optimal usage for the pods and the nodes. However, this is not an exhaustive list. I just mentioned few important decision criteria. There could be much more, but we can start from here.